product is going to be using sign. Okay, thank you, Ian. Now, other people muna ako there. Alright, it is what it is. If they show up, they show up. It's completely fine. So again, like I was saying, cross product or vector product. So the cross product of two vectors, u and v, is defined by the following. So we get u cross product v is equal to the magnitude of u times the magnitude of v times sine of theta times the unit vector n, where theta is between 180 and 0, and the unit vector n is the unit vector perpendicular to both u and v. So since the quantity on the right is a product of three scalar quantities and the unit vector, the result is a vector, it is also called a vector product. Okay, so when we do the cross product, we end up getting another vector. So the cross product of two non-collinear vectors is a vector which is perpendicular to both u and v. Therefore, the cross product is only defined in a three-dimensional space. So u, v, and n, and the unit vector n, form a right-handed system as indicated in the following diagram. So I have my vector u going this way, I have vector v going this way, and my cross product is noted by this vector over here, and my unit vector is noted by that. So this is down into page. Now up into page means that I have my vector u going this way and my vector v going that way, but my cross product of u cross product v is going upward or up out of page. Okay, so with this we can conclude that the cross product of u and v is not the same thing as the cross product of v and u. Who just came in right now? Okay. Now I'm just missing 4 other people. Whatever. It's fine. So we're going to place yourself at the tails of the two vectors you are crossing. Now place your right hand on the diagram so that your fingers curl in the direction of rotation from u to v. Through the angle of less than 180, your thumb points in the direction of the cross product. It's kind of weird to do it with your hand. I don't know if you guys can do it at home. I used to remember how to do it back in high school. I don't know how to do it anymore. So the magnitude of the cross product of two vectors is the magnitude of u cross product v is equal to the magnitude of u times the magnitude of v times sine theta, where again theta is between 180 and 0. So now let's get into some examples. So example 1, for each vector pair, find the magnitude of u cross product v and state whether u cross product v is directed into or out of the page. Okay. So let's use our definitions. So I know that the magnitude of vector u cross product v is equal to the magnitude of u times the magnitude of v times cos of theta. Sine theta, my mistake. So I know my magnitude of u is going to be 11. My magnitude of v is 9. I'm going to take sine of 50. So I get this is approximately 75.84 units, or the magnitude is 75.84. So because my theta is an acute angle, based off the diagram at in the first page, I can therefore conclude that my direction is going into the page. So therefore, u cross product v is equal to approximately 75.84 units into page. So now I have my next one, which is b. So I have my magnitude of v is 15, and my magnitude of u is going to be 24, and my theta is 115. So again, I take u cross product v is equal to the magnitude of u times the magnitude of v times sine of 115. So I get 24 times 15 times sine of 115, which gives me approximately 326.27 units. And because of my angle, my direction is going to be out of page. Which means u cross product v is equal to approximately 326.27 units out of page. So now we're going to get into some properties of cross product. So I have u cross product v is equal to negative v cross product u. This is known as the anti-commutative law. I have u cross product v plus w. This is the same thing as saying u cross product v plus u cross product w. That's the distributive law. And the last one we have k times u cross product v is equal to k times vector u cross product v, or u times vector k cross product times vector v. So now I have to figure out the cross products of the basis vectors I, j, and k are of particular importance, okay? So if I have the vector I cross product I, using our information that we have about the cross product, I can write it as magnitude of I times the magnitude of I. And because they're the same vector, it's going to be multiplied by sine 0. Okay? Which means that I get the 0 vector. So any vector that is a cross product to itself is going to give you the 0 vector, because sine 0 gives me 0 because they are the same thing. There is no angle created, which means that I get the 0 vector. Now I get A cross product I. Okay? Vectors I, j, and k are what to each other? Are they perpendicular or not perpendicular to each other? So if I draw just vectors I, j, and k, they're perpendicular. Thank you, Priyanshu. So I can simply write this as I times the magnitude of j times cos of 90, okay, because these vectors are perpendicular to each other.
Is it sine of 90?
Pardon? Oh, sorry.
Is it sine of 90?
Keep thinking cosine. Sine of 90. And because they are perpendicular to each other, and they all intersect at 90 degrees, when I take the cross product of I and j, it gives me the vector k. That is its cross product. It's the remaining, it's the vector that is left over, which is k, because they all intersect, or they all meet each other at 90 degrees. Which means that j cross product k would give me I, and k cross product I would give me j. So because we know that I cross product, because of the first page example, it says that U cross product V cannot equal V cross product U. So I cross product J is not the same thing as J cross product I. When we do the cross product of J and I, this is going to give us negative K. See if anybody else showed up. When we take the cross product of K and J, we get negative I. And then we get I cross product K, which is negative J. And you guys will come to know this when we actually start figuring out how to calculate the cross product of different vectors. We're not going to do example 2 because I want to get into the whole cross product and component form stuff. So now we're actually going to figure out how to determine the cross product of any two or pairs of vectors. So for example, if U is equal to U1, U2, U3, so U1, U2, and U3 are a set of numbers, and vector V is V1, V2, and V3, then the cross product of U and V is the second term in the U vector times the third number in vector V. What do you mean you got different answers for example 1? Also, you're getting out of page for A and into page in B? Is that what you're getting? Okay. Give me 2 seconds to come up with the explanation that will hopefully make you understand it. Give me 2 minutes. No, it's fine. I know how to explain it. So for example 1, if I were to draw my U cross product V, where the hell is my marker? I'm going to draw it right here. It is contained within the 2 vectors, which is why it is considered down and into the page. Okay. However, when we have a very large obtuse angle, and if I were to draw my U cross product V, my book is opening this way, which means my U cross product V is going to be going out of the page. Yep. You're welcome. So now with the cross product, like I said, this is the notation for it. So I can do it in terms of a chart. So for example, I take my U1 and V1 outside. I would not consider those. And then I would write U2, U3, then back to U1 and U2. So you go in order, then start over again. And then you're left with U3 at the end and V3. You do not count those. So what you're going to be doing here is you're going to be multiplying these vectors together. Okay, so always down products minus up products. So let's take an example and I'll explain it better. So I want to find the cross product of U and V for each of the following vectors. So again, let's take my order. So I got 7, -2, 1, 7, -2, 1. I get 4, -1, 3, 4, -1, and 3. So we disregard our first vectors because that is not part of our cross product notation. So now to get U cross product V, I need to multiply. And I'm going to get another vector. So I'm going to multiply -2 times 3. which is negative 6, minus negative 1 times 1, which is negative 1, comma, 4, 1 times 4, which gives me 4, minus 3 times 7, which gives me 21, comma, 7 times negative 1, which is negative 7, minus 4 times negative 2, which is negative 8. Which means that my cross product of these two vectors is going to give me the vector negative 5, negative 17, and 1. So remember, this is my x, this is my y, and this would be my z. So now the next one I have, u is negative 1, 7, and 3, and v is 2, negative 5, and 9. So if you guys want to take a couple of minutes to figure out the cross product of u and v, and then type in your answer in the chat, I'll give you guys a couple of minutes to do that. Okay, so did everybody get what Ricardo got? 78, 15, negative 9. Perfect. So the cross product of u and v is going to give me 78, 15, and negative 9. So now to check your answer, you can take that cross product of u and v and cross product it to any vector u and v, and it should give you 0, which means that they are perpendicular to each other, which means they give you the 0 vector. So if u and v are two non-collinear vectors in a three-dimensional space, then every vector perpendicular to both u and v is of the form k times a cross product b, for k is an element of any real number. So we have example 4. If b is equal to 8, if vector b is 8, negative 2, and 5, and c is negative 1, 6, and 0, and d is negative 4, negative 3, and 9, find b cross product d and take that cross product and dot product to vector C. So let's start this one together. Let's start with B cross product D. So again, let's do our chart. So again, I got 8, -2, 5, 8, -2, 5. And then I got D, which is -4, -3, 9, -4, -3, and 9. So again, disregard the first and last one from each one. So I got -18 minus -15. And I get -20 minus 72. And I get -24 minus 8, which gives me a cross product of -3, -92, and -32. So now I want you guys to do the last part, which is to take my cross product that I got and dot product it to vector C. So what would B cross product B dot product C give me? So I have to take this guy now and dot product it to my vector C, which is -1, 6, and 0. So who can tell me what my result is going to be? And see if you guys remember how to do the dot product. Let's see what you guys get. Once you have your answer, type it out in the chat. If you're wondering what your dot product is, it's going to look like this. Maybe some of you forgot, which is okay. That's going to be -3 times -1 plus -92 times 6 plus -32 times 0. So what would that give me, guys? -549. Perfect. All right, good. And then our last example for the vectors A, which is -1, 3, and -2, and vector B, which is 3, -9, and 6. Sebastian's here. Anna, do you know where Madge is or no? Just text her, be like, where the hell are you? All right, so for example 5, for vectors A and B, I want to show that A cross product B gives me 0 and explain why this is true. In general, show that ABC cross product KA, KB, and KC is equal to 0. So if you take my A cross product B, we are going to get 18 minus 18 times -6 minus -6 times 9 minus 9. Which gives me 0, 0, 0, which gives me the 0 vector. All right. Now, in order to prove this, I need to show why ABC cross product KA, KB, and KC gives me the 0 vector. So let's show this proof. So let's take A, B, C, and take the cross product of KA, KB, and KC. And we need to show that this equals to 0. So when I do my cross product and I set it up the way I usually set it up, with ABC and ABC on the top, and then KA, KB, KC. So remember, it's going to look something like this. So I got ABC. And I got KA, KB, KC, KA, KB, KC. So now let's take the dot product, the cross product of these. So my first one is going to be B times KC minus KB times C, comma. My next one is going to be CKA minus KCA, comma, AKB minus KAB. So is BKC the same thing as KBC? Yes or no? Yeah. Because of the cumulative property, when the numbers are being multiplied together, I can put them in any order, and they're going to be the same. So these cancel each other out, which gives me 0. These guys cancel each other out, which gives me 0. And these guys cancel each other out, which gives me 0. Which means that my final answer is going to be the 0 vector. Okay? So even when we multiply the second vector by any scalar, we're literally going to get the 0 vector because everything just cancels each other out at the end of it. So when the cross product gives you the 0 vector, or you get a 0 cross product, that means that two vectors either have the same direction or have the exact opposite direction from each other, which means that either one of them has a 0 length, which is why their cross product can be 0.